Hi, I'm Matt, and let's discover who's naughty and who's nice. So, I taught an AI how to lie, and I'm going to walk you through that project here, and we're going to get into it a little bit more. But first, if you don't know me, here's a little bit about myself. I teach software engineering professionally at a 14-week boot camp. It's a lot of fun, and when I'm not doing that, I am studying a lot of things around artificial intelligence, data science, machine learning, and I'm sharing those things with the community through my blog, YouTube channel, and talks in my community. Okay. So normally I specialize a lot in Microsoft technologies, including .NET/C Sharp, a little bit of F Sharp occasionally. I also do a lot with Microsoft Azure, including Azure Machine Learning Studio and Azure Cognitive Services. This talk isn't really about any of those things, though I did write this project in .NET 7 using C Sharp 11. But I want instead to talk about the high level concerns that you might have when you are designing an artificial intelligence application of your own, and the kinds of considerations that you might bump into, as well as how you might choose to test it. Okay, so let's take a look at the project, and I hope you're going to be entertained and educated. So my favorite card game of all time is One Night Ultimate Werewolf by Bezier Games. Now, this is not an exclusive copy that has a transparent background. This is really just a rather unfortunate aspect of having a green screen and a yellow moon on the cover. But One Night Ultimate Werewolf is a party game where you can play in about 10, 15 minutes each game. So I used to play this over lunch with a bunch of other engineers, and we learned not to trust each other very well as a result of that. So it's a social deduction game where you start out with a card, and that's your role, and nobody else knows what your role is except for you. And each role might get some abilities that they can do during the pre-game phase. And then the main game is kind of deducing who's who and who did what during the night before the game began. And you're ultimately trying to determine who do you want to vote for. Every player has to vote for somebody, and the player or players with the most votes on them at the very end, when the announcer says 3, 2, 1, vote, they are killed. And the goal for the villager team is to kill at least one werewolf, and for the werewolf team, it's to not get killed. Right, so you're trying to figure out who has which card, and what did they do, and what did you see, and what can you prove. And it's a social deduction game. You're trying to understand what you want to bluff as, or what your neighbor is bluffing as. And you also have an understanding of the number of roles that are in the game. So I'm going to kind of walk you through what a typical game looks like using the game cards, and then we're going to take a look at my application that really simulates this. That shows AIs playing really against each other. This is a project that's currently in process, so it's not going to be perfect. But my goal was really to find an AI that could potentially trick me with its lies, and this technically achieves that objective. So let's take a look at a gameplay, and I'll show you my app, and we'll talk about where this is going next. All right, so here we are at our sample game of One Night Ultimate Werewolf. In One Night Ultimate Werewolf, you always have three more cards than the players you're going to have. You always have at least three players. So here I've got my three simulated players. I've got John McClane from Die Hard. I've got the 11th Doctor from Doctor Who. And then I've got Doug from Up. And each one of these actually represents a separate data science project that I've done in the past. And whenever I do a new data science project, I go out and I get a new bobblehead. So Professor Lupin from Harry Potter is representing this data science project. So I guess he'll watch. Uh, but you kind of shuffle the cards, and each player is going to get a role assigned. But first, let's kind of look over what each of these roles are. The first one we want to look at is the werewolf. With the werewolf, that's just your big bad. That's the thing that you're trying to find. Werewolves don't really have much of a special ability, except they get to wake up in the night and find out if there's another werewolf at play. If there's not another werewolf in play, they get to look at a card. The Mystic Wolf is a special werewolf card added in the Daybreak expansion. It's a werewolf, but it also gets to look at one other player's card, so it gets a little bit more information. And as you're going to see, information is power in this game. Mason is a townsfolk role. It's on the good team, and whenever a Mason is in play, there's always two Masons in play. And Masons don't really get to do anything except for see if there's another player that happens to be a Mason in this game. And that doesn't sound that powerful, but it actually turns out to be very, very powerful because you know you can trust somebody. It also gives you a little bit more freedom to lie as well because you got somebody to back you up. Next up, we got an Apprentice Seer. The Apprentice Seer gets to look at one roll from the center cards, that's the cards that are not in play, and they get a little bit more information there. And finally, we have a revealer. Okay, revealer is a very powerful role. It actually gets to flip over another player's card, and if it's good, that card stays face up, and if it's bad, they have to turn it back over, but they still know what they saw. And together, these things kind of give the good team some information, and they give the evil team some information. And the game is ultimately about trying to bluff. So when the game starts, you kind of draw out these cards. And so I'm just going to shuffle these up in a very bad mat shuffle. Dexterity is my dump stat. But we're going to give Doug our Mason card. We're going to give the Doctor the other Mason card. And we're going to give John McClane our Mystic Wolf card. This isn't exactly good for teaching purposes, so I'm going to instead give the Apprentice Seer to Doug. Okay? And the remaining 3 cards are going to go face down in the middle. So these players get to look at their card, and nobody else gets to see that card. So I'm going to flip them back over, so just to kind of simulate what we would see in a game. Okay? But we know that that good old John McClane over here is our Mystic Wolf. We know that the Doctor is our Mason, and we know that the Apprentice Seer is actually our Doug from Up. Okay. Now these cards have a specific order that they go in. So the announcer, there's an app that goes with this game, and it'll say everybody close your eyes, and then it'll say werewolves wake up. And so John McClane opens his eyes, sees that nobody else has opened their eyes. He knows he's now the only werewolf. Since he's the only werewolf, he gets to look at one of the center cards, and he looks over here and he sees it's a Mason. Okay, well that's information he has that nobody else does. Next, an app says, okay, werewolves go to sleep, so John McClane takes a snooze. It says, all right, Masons wake up. So the Doctor wakes up, looks around for other Masons. There is no other. So he knows there's no other Masons in the game. He knows the other Mason card has to be in the middle. We know actually it's right here, but he doesn't know that. It says, okay, Masons go to sleep. Now it says, Apprentice Seer. Apprentice Seer, wake up and take a look at a center card of your choice. So that'd be Doug from Up, and he goes over and he says, okay, I'm going to take a look over here. And he says, oh, okay, the werewolf's in the middle. And it says, all right, now close your eyes. Revealer, if you're in the game, uh, flip over somebody's card, and if it's evil, flip it back over. Well, there is no revealer, but if there was, they might flip over this, and they'd see it's good and leave it up, or they'd flip over werewolf, and then they'd have to flip it back over. So that's kind of the flow of the night phase of the game. And then everybody really wakes up at that point, and they're saying, "Hey, all right, who are you? What did you claim?" You know, and each player goes around and they claim a particular role. Okay, so Doug might start out and saying, "Well, hey, I am the Apprentice Seer. I took a look at a center card, and I know the werewolf. Oh, whoopsie doodles! I know the werewolf's right here." And then he might say, "Hey, I am the Mason. I know that there are no other Masons in play. I know that one of these center cards has to be a Mason. So what are you, John McClane?" And now John McClane has an interesting proposition because he can claim to be one of these roles that's not claimed before. So he could claim to be the Revealer, or he could claim to be the Werewolf or the Mystic Wolf. He could also claim to be the other Mason, but then they would know that one of these two players is lying. So he might choose to claim to be the Revealer, and then accuse another player of lying. And now we have kind of this contradiction. And so you ultimately have players trying to convince each other that one of them is telling the truth, or find out if nobody is evil at all. But at the end of the time, that there's a timer running, and it says, okay, your time is up. Now everybody 3, 2, 1, point at another player, and then the player that has the most votes, you turn your card over. Let's say that John McClane's not able to bluff his way out of this. He gets both of those players to point at him. They turn over his card. He sees he's the Mystic Wolf. Oh, yeah, so he might have also gotten to see another player's card there as his ability. But that's kind of the flow of a game, is you're trying to deduce who everybody is, you're trying to keep your role hidden, you're trying to find a safe bluff to take from the middle cards if you're an evil role, and deflect blame off of you and maybe onto another villager, or just off of you in general. So that's really the flow of One Night Ultimate Werewolf, and this is what I built as a simulation. Okay, so let's take a look at this app. So I wrote this app in .NET 7 and C# 11 because they're new and shiny. and WPF, or Windows Presentation Foundation, because I have a lot of really good skills in that area. And it made sense to me to make an app fast instead of using a more modern approach, such as Maui or one of the more recent versions of desktop application development. But here is my desktop application. I've got a four-player game just starting out here with Santa, Rudolph, Comet, and Blitzen. We're looking at this from Santa's perspective, and Santa has drawn Revealer. So we see our player cards over here on the top, and then the three center cards are going to be down here in the lower row. We also see the in-game roles over here. We see that because it's a four-player game, we had to add one more card, and I added the Villager card, which is just a town role that doesn't have any knight abilities, no special abilities for the town role. Okay? And so over here on the right, we have the events of the game. The game is really powered by events. We see this stream of events that some players get to observe, but not all. Okay? I'll show you storyteller view afterwards, and so you can kind of see the whole picture of the thing. By the way, the source code of this is available if you want to poke around. The code's not amazing. I need to clean up a lot of it, and it's still very much a work in progress. I'm going to keep tinkering with for fun. But my goal is really just to play around with AI and have some fun with this, so I hope you get some enjoyment out of this project. Let's walk through what a sample game looks like. So the game starts out with Santa being asleep, or all players being asleep. And the first phase is werewolves wake up and see each other. If there's only one wolf, look at a card from the center. Well, Santa's not a wolf, so he keeps his eyes shut. He doesn't see anything that's going on right now. Other players might. Next, we have the Mystic Wolf. If you're awake, go and look at another player's card, so you get that added information. Okay. Finally, Masons wake up and see if there's another Mason in play. Again, Santa is not any of those roles, so he doesn't get to observe any of these events. Apprentice Seer, choose a card in the middle to view. Well, that's not Santa. Next, Revealer, wake up and flip over another player's card. So Santa wakes up and flips over Blitzen's card. It's a good card, so it stays face up. So now when all the other players are going to wake up, they're going to see Blitzen's card face up. They're going to know Blitzen is a good player and we should not vote for them. Okay, so as we're going along, we're actually tracking a lot of probabilities that go along with the game. So I can check on this show probabilities, and we actually are tracking the probable roles that might be in any given spot. And as we get more information, Santa's perspective of the game actually changes a little bit. So I'm going to turn that back off. We'll look at it again in a second playthrough here, but let's just see the experience from Santa's perspective. Next is the day phase. Everybody's going to wake up, and now everybody sees that, Blitzen's card is face up. So they know exactly who Blitzen is. They know Blitzen's good. They also know there's a Revealer in play. Santa immediately claims to be the Revealer and says, to the shock of everyone, I flipped over Blitzen's card. And Blitzen is a villager. Rudolph then decides to wait a little bit before claiming their role. Evil players that are not certain of their role will often defer. I also have coded it so that there's a 35% chance right now that a good player might defer, just to look a little shady and to make it a little bit more uncertain. So you can't just make your guesses based on if someone who's deferring or not, but it's a little suspicious to defer. Comet claims to be a Mason, and it claims that no other players were a Mason. And Blitzen, to the shock of everyone, claims to be a villager. Okay, that's our initial round of claiming. So if anybody deferred, now they have to claim a final role. Rudolph now claimed to be the Apprentice Seer, and they chose center card number 2, and they say it's a werewolf. Well, if we look at our probabilities, there's a 20% chance that card might be a werewolf. There's nothing that we have that really that contradicts that. There's nothing that we have that contradicts Blitzen. We know Blitzen's good. I don't know if Comet is going to be actually a werewolf or the Mason like they're claiming. We just don't have quite enough information. So now we have the choice of, are we going to vote for Rudolph? Are we going to vote for Comet? Are we going to vote for nobody? In an actual game, I might choose to vote for Rudolph or whoever seemed the most sketchy. Rudolph seems a little sketchy there just because they chose to defer. But let's see what these AIs choose to vote on. So next we're doing their voting phase. And Santa chose to vote for Comet. This is all AI controlled. There's no manual control yet. Blitzen chose to vote for Santa. For some reason, that's not a very smart vote, but I haven't improved the voting AI yet. I'm just working on the claiming AI at the moment. Um, Rudolph chose to vote for Santa, and now Blitzen voted for Rudolph. So we count up the number of votes that a player has, and the player or players that have the most votes over one die. If there's no bad rolls in play, then you really actually want everybody to get one vote so nobody dies. But that's kind of an edge case. So here in this scenario, we'd flip over Santa's roll. Everyone would see it's a revealer, and so you'd know that you killed a villager. You didn't kill a werewolf. So now we get to see, who is everybody? And we say, oh, Rudolph with his nose so bright, he was our mystic wolf, he was our baddie. And so Rudolph would win this game and everybody else would lose. Now, it wasn't really a great idea for the villager here to vote for the revealer with nobody else claiming revealer. The revealer was basically confirmed. So folks should have either voted for Rudolph or Comet in this scenario. But again, I've been focusing on the claiming AI and the probability logic versus the voting AI, which is going to come, in the new year, I would imagine. But this is really what a game looks like. So let's. The cool thing about this is if I was a human player in Santa's shoes, I might not have guessed that Rudolph was our baddie. I might have guessed it was Comet. I might have guessed it was nobody. So this is a case where the AI was actually able to act in a way that fooled me or somewhat fooled me as an experienced player. I was suspicious, but I wasn't certain. Okay? And that's what we're looking for with AI in this case. So let's take another look at another game from the perspective of the storyteller, and we'll see how all this works. All right, so here's a new game with the storyteller perspective on. So the storyteller gets to see everybody's perspective of the game, and they get to see all the events that occur. So as we go through the game, we get to see everything that occurred, all these events, and there's some additional diagnostic events you can include, such as when a player wakes up, they know that none of the other players is a werewolf. So Santa, by waking up in the night, knows that Rudolph and Comet are not the mystic wolf or the werewolf, just because they didn't wake up with the other werewolves. Yeah, I have those hidden by default, but those are events that I have flowing through the system because they impact the probability model for determining what a player may or may not be. Okay, so all of this is really based on probabilities. So right now, Santa's got a pretty good idea of what other players are, right? What their roles are, and as the game kind of progresses, as he gets a little bit more information, because he's going to get to look at another player's card here, and he chose to look at the Mason. So now he knows, like, oh, okay, I know you're this, and I know you're not over here. So I have some pretty good inferences I can make. This is actually a bug over here I'm noticing. This shouldn't be a chance of being a werewolf because he knows that Blitzen's the other werewolf. So I'll fix that. But this is kind of the overall idea. We see this model of probabilities going on. And, our Mason right now has no idea what anybody else is. But as he gets to wake up, he gets to see, oh, there are no other Masons in play. So I know you can't be a Mason. I know you can't be a Mason. I know you can't be a Mason. I know the Mason has to be one of these three roles over here in the center. So he's building his own probability model. Comet's got a completely different one. He has no idea of what's going on. And as he gets his turn, well, now he knows that none of these cards can be a villager because the villager card is right over here in the center. So each player has their own kind of individual set of events that they have access to and their own individual probability model for the game. So the game is really all about rolling probabilities. And when the AI is making claims, when Santa's going to need to make a claim in a moment here, we're going to look at what does Santa know is in the middle, or what does Santa think is in the middle, and we'll see what choices he makes. So the revealer now wakes up. I can't recall. Yeah, there is no revealer in this game. And now we're starting our day phase. So here, we see Santa has a decent bit of information. He's got a little bit more information than Blitzen does because Blitzen didn't get to look at the other player's card. Rudolph knows that there is no other Mason in play, but that's about it. And then our apprentice seer knows that there's a villager in the middle. Okay? So we'll see what people are claiming. So I'm going to go back to storyteller view so we get all the events. And the very first thing that happens is we have Santa decided to wait before claiming their role. Okay, makes sense. Santa's not sure what everybody else is going to claim, so he chooses to defer. Rudolph then chooses to claim that they are the Mason, and there were no other Masons claimed, and Comet claims to be the apprentice seer, and says, "Hey, this card right here is the Villager." Okay? Blitzen then decides, I'm gonna wait too. I'm gonna wait before claiming. So these wolves are deciding to wait a little bit and bide their time, but they now know that somebody's claimed a Mason, somebody's claimed the apprentice seer, and somebody has knowledge of the Villager. So realistically, one of them should claim to be the Revealer, and one of them might want to claim to be the Mason. And this is a scenario where they're actually going to be forced to start accusing other players, and I don't have a lot of code for that yet. They're actually going to start to be antagonistic in a real game, is what would have to happen. So now Santa claims the Villager. So Santa's basically saying Comet's lying. Comet didn't see this. So in a real game, Santa would now start pushing on people to vote for Comet, because Santa's not going to claim to be the Mystic Wolf, because then he'd get voted out. So that's his tack. So we'll see what Blitzen claims here. Blitzen then claims to be a Revealer who skipped taking their night action. If I was in Blitzen's shoes, I would claim to have revealed Comet as the werewolf. That's what I would probably have claimed in a real world game, because Santa would be pushing suspicion onto Comet. So I've got a little ways to go here on the AI, but the claim AI is actually pretty good. Just the social deduction, social interaction, and voting AI, it needs some work. Okay, but as we're going, we just have this set of probabilities that each player has, and their voting is really based on that type of probability. It needs to be based a little bit more on suspicion at the moment. It's very dumb, but that's what's going on in this early prototype AI. Okay, so let's talk a little bit more about where this project is going and the kinds of choices that you might choose to make while developing an AI for this or something like this. So let's talk about where this project is going, or where I see it going. So first of all, this is, of course, Bezier Games' legal property. I'm really only doing this as an experiment for fun, to teach other people, and really as a way of exploring what a fun and balanced game this is. I want to be able to generate some win-loss statistics for all the different roles with all the different strategies and share those with the community. I think that'd be really interesting to find. Um, so second of all, this code is all open source. It's not for any commercial use, of course, because Bezier Games owns the IP, as I mentioned. But if you're curious about this, if you want to tinker with it, if you want to start adding features and sending me pull requests, chat with me. But you can go out to github.com/integerman, and you can find that under the where doggo repository there. uh, but let's talk about the short-term AI approaches that I'm envisioning to make this a little bit better of an experience. So as you saw from some of my playthroughs there, the AI is okay at claiming roles, but it could be a little bit more aggressive in some cases, such as what it claimed Revealer that skipped. That's going to get you voted out every time in a real game. Okay, but the in order to do that, you need to move from not just a probabilistic model of where each card might be. You need to start looking at all the claims people are making and saying, is this suspicious? Is this, do I know this to be false? Do I know this to be true? And so you start saying, okay, well, who's telling me things that I know are true, and who's telling me things that I know are false? And you start, learning who you're trusting and relying on their information as well as your own. Okay? So that's kind of the short term of where this is going. Is each AI agent is going to look at each claim and saying, is this suspicious? Is this not suspicious? Do I have an opinion on this? And using that to impact their suspicions. And then next thing I want to do is each AI agent is going to say what their opinion of every other player is, and that's going to let other people say, okay, well, I trust them, and they think this player over here is suspicious. I'm going to vote with them for that player. And so you can start to kind of coordinate votes. And that's actually really important for the werewolf team to have a good chance of winning if you get multiple werewolves in play. Right? So vote coordination is a really important thing. Sharing suspicions is a really important thing. But that's kind of our short-term goals. Longer term, I want to do a lot more with actual AI versus probability. So I want to start looking at modeling all the possible start and end states that a card might be on a given board. Right? I say end state because there's actually roles, such as the robber or the troublemaker, that can move roles around during the night. So you might have started as the villager, and you might have wound up as the werewolf. And part of the fun of One Night Ultimate Werewolf is figuring out who everybody started as, but also which team are you on at the end of the game, because it might have changed. Um, but I need to have a much more complex model of the world and the way the world works, um, in order to support that. So I want to have an approach that models all the possible states, and then say, given what I know, given what people are claiming, how likely is each world, and given the likelihood of each of these scenarios, this is how I think I ought to vote. There's a lot of uncertainty in Werewolf, and that's part of the fun. We're not going to be looking at like the social ticks of somebody. That's really the human version of this game. I'm looking at more of the mathematical and machine learning aspects of this game, right? The other approach I want to try is I want to take a look at each phase of the night. So if there is a revealer, for example, there might be possible events that might occur. So if I'm player A, player B might be the reveal, and they might have chosen to reveal player A, B, C, D, E, whatever it might be. And so there might be some sort of a world that you might consider, like, hey, that might be a possibility. What's the percentage of likelihood of this? And so your AI is sort of brute forcing this and saying, like, I got all these different possible worlds. Is this possible given what I know? How possible is this? And using all of these things to inform what team you think you are on, and who you think you ought to vote for at the end, as well as what claims you might want to make. Now, a common approach in AI is to have certain specific playbooks for common scenarios. So, for example, if you wake up in the night as a werewolf and you see you have a werewolf friend and there are Masons in the game, well, the two of you might claim to be fellow Masons who have seen each other. And even if there's another player who actually was a Mason, well, they might be on their own. And so now it's two players saying, no, we're the Masons. This guy's the werewolf. Let's vote him out. That's part of the fun of One Night Ultimate Werewolf. And so coding in, like hard coding some strategies like that might be a good middle term solution for that. But where I ultimately want to get with this project is I want to get into reinforcement learning. So an AI could actually play this game and try a bunch of different strategies and track its win-loss ratio with a bunch of different aggression levels, or uh, subterfuge levels, or whatever it might be. I got to figure out some set of traits that a player might have as far as what they might claim and how aggressive they might be and things like that. But I might want to morph it over time and say, like, hey, here's the optimal settings for somebody who draws the werewolf card. Here's the optimal settings for somebody who draws the villager card. And so using reinforcement learning, the AI can try all sorts of different approaches using something like a genetic algorithm or a neural net with a back propagation. You could train something like that to find some optimal behavior strategies. And that's what really interests me about this project. I want to see what machine learning can tell us about this game that I really, really enjoy playing. I want to see what hidden strategies that it thinks are there, at least in my version of this game. Because remember, I'm not modeling a lot of the social aspects of it. I'm not modeling of, oh boy, Bob seems really nervous right now. No, this is all about who's claiming what and how likely is that claim. So if we're taking human emotion and human verbal ticks out of it, what's the optimal strategy? So that's kind of where I'm looking at going with this project. With your own AI projects, you're going to usually take a look at a lot of different approaches, and you might prototype out a few things. You might say, hey, let's try representing the world as a tree. And it was like, oh, this is really computationally expensive. This is really hard to do. It's like, okay, well, we can look at tree pruning and things like that, and min-max algorithms, and all these solutions that people have come up with these specialized problems in the AI world, or we could try something else. And there's often some very simple things you can do that have a really good effect. So this application I showed you is really just one major trick, and that's we're modeling the probability of a card being at any given place, and we're tracking what people have claimed, and the evil AIs are trying to avoid conflicting with each other, and they're trying to avoid conflicting with existing claims, but that's not always possible, as we saw. So let me know what you think of the project. Let me know what questions you have. I'd be happy to chat with you. I am at IntegerMan on Twitter. You can also email me at matt@mattondatascience.com, or connect with me on LinkedIn. But stay tuned. I hope to tweet more about this project as I get time. It's not a high priority project for me, but it's a very interesting one. So happy learning, happy playing, and enjoy the winter.